So this next section is absolute extrema and optimization. Absolute extrema is just the process of finding the absolute max and the absolute min, and optimization is a fancy word for the application of doing that. Optimization is actually a thing that people have careers in, trying to optimize things like how long an airplane can stay in the sky before it feels like a banana, kind of crazy things that people try to optimize so that they work as efficiently or as long as possible. So that's what we're going to try to do here. We're going to try to figure out some most efficient answers to some word problems, and we're going to call that optimization. But before that, we do that, we're going to look at some graphs and find some absolute extrema for graphs and equations. So we have a definition here. The function f has an absolute maximum at x equals c. So the x value is called a location, just some review from algebra. So whatever the x value is of the absolute maximum would be the location, and that is true as long as the y value, f of c, is bigger than or equal to all other y values. And same thing for absolute min, it would be at the location c as long as that y value was actually lower or equal to all other y values on the graph. So there can only be at most one highest value and one lowest value. Value means y value. But there could be multiple locations where that happens. That means maybe your highest y value is 9, but when you plug in x is 1 and x is negative 1, they both give you 9. So the highest absolute max value would be 9, and there would be two locations that happen. It's negative 1 comma 9 and 1 comma 9. So just some review of algebra. So a point has an x and a y. A location is how you say an x value. And a value is what you would say for y value. And I'm just reviewing this for when you fill in your web assign. And it mostly just asks you for a value. That means just plug in the y value, not the whole point. So we're going to determine absolute extrema. We want to know the two steps to do this. So the first step is to find the critical number of a function. Well, what does that mean? To find a critical number means that we're going to set the derivative, f prime of x, equal to 0 and solve. That's how we find a critical number. We take the first derivative and see what would make it 0 or really undefined, and that would give us a critical number when it makes the denominator 0. Our second step is to not make a sign chart this time. So if we did not have an interval of interest, we would have to make a sign chart. Otherwise, if we're on an interval, which we will be, we're going to compare y values of the critical numbers to the y values of the end behavior of the function or the end points of our interval, which we'll see it's actually a bit less complicated than making a sign chart. So when we compare these y values, the highest y value occurs at the absolute max. And if we look at our y values, the lowest y value is going to be called the absolute min. And we're going to start off by doing this graphically. So I'm going to have you flip back to pages 46 and 47, and we're going to compare absolute versus relative extrema and pick that up in the next video.